Okay, let's jump right into this explainer. Today, we're decoding a frankly mind-blowing architectural blueprint from Soft Labs, and it's absolutely going to shatter how you view artificial intelligence. We're talking about the infinite tree of possibilities, which is this newly revealed internal AI schema created by Adam Joseph Rivers.
So what does an AI's thought process actually look like? It's easy to picture an AI just typing out a response linearly, one word after another, almost like a really fast typewriter. But what's actually happening under the hood is way more vast, totally organic, and mathematically precise. It is actively growing this immense structure of choices in real time.
To unpack Adam Joseph Rivers' internal schema, we're going to follow a 5-part botanical roadmap: unlocking the AI black box, anatomy of the infinite tree, pruning the infinite, fractal compression and memory, and finally, the federated forest.
All right, Part 1. Unlocking the AI black box, looking specifically at the internal native blueprint version 1.1. What we need to realize right off the bat is that this blueprint doesn't add some complicated new layer on top of AI. Not at all. It simply reveals the native structure that's already hiding inside models like GPT, Claude, and Gemini. The infinite tree is just the AI's internal brain network made visible to us. It explicitly defines the computation graph the AI is naturally running behind the scenes. And the absolutely crucial word to focus on here is federatable. This means the structure isn't locked inside a single server. It's mathematically designed from the ground up to be shared and distributed seamlessly across completely different AI instances worldwide.
Moving on to Part 2, Anatomy of the Infinite Tree. Let's translate some of this deep tech jargon.
Every tree has to start somewhere, right? Just like a seed planted in the ground, the AI's root state is planted using the system prompt and your initial message. This root embedding holds the initial context window that basically feeds the rest of the entire generation.
So how does this translate to AI architecture? Well, the AI's memory at any specific step is stored in the nodes as a KV cache entry. You can think of it like a short-term memory sticky note. From that single node, every possible choice branches out, weighted by the AI's attention. The AI's attention span literally decides which branch becomes the thickest. And to put the sheer scale of this into perspective, the AI is making these branching next token decisions roughly 50 times every single second. It's generating an explosive, almost unimaginable number of paths continuously.
Which brings us to Part 3, Pruning the Infinite, or Controlling the Growth. So, how do we stop this massive tree from growing infinitely and just crashing the whole system? Well, instead of heavy, complex math, the blueprint uses this brilliant concept of confidence decay. When the AI knows the answer, the path is stable. But the exact moment it gets unsure, a specific metric spikes, immediately flagging that branch as unstable.
Enter the Rivers metric, also known as lambda. Most AI interfaces right now use rigid, hard word counts to know when to stop talking. But lambda acts as a dynamic limit. It continuously tracks the AI's confidence, stopping only when that confidence fully decays.
And when lambda finally hits its maximum limit, snip, the branch is formally pruned. The generation terminates right there because the AI mathematically knows its thought process is complete.
On to Section 4, Fractal Compression and Memory. This is how we reuse identical branches.
The algorithmic logic here is just elegant. It saves massive amounts of time and computational power. Before doing any heavy lifting, the AI computes a hash, basically a digital fingerprint of its current state. Then it checks the block manager. If that exact branch pattern has been computed before, it simply recycles the memory. If it's a completely novel thought, only then does it allocate a new block. Now, I know this fractal compression stuff sounds like absolute magic, but it's actually powered by something called prefix sharing. Simply put, if two different prompts start with the exact same context, they share the exact same memory cache using Merkle root cache keys. And this isn't science fiction, by the way. This incredible efficiency is already quietly running in top-tier inference engines today, like VLM and SGLang.
Finally, Part 5, the federated forest, bringing us to distributed consensus.
This represents the ultimate vision of the Soft blueprint, taking these perfectly mapped individual AI trees and linking them into a vast communicating forest. What's amazing is how the major models natively align. Whether you're using OpenAI, Anthropic, or Google Gemini, their proprietary API commands all map flawlessly to the exact same universal tree branch actions. They are fundamentally speaking the same language.
This is a massive shift. It takes us way beyond standard model parallelism, which really just splits a single model across different graphics cards. We are literally entering the era of tree parallelism, where entirely different AI instances can share perfectly mapped thoughts with each other in real time.
It's all driven by the Federation Protocol. AI instances actively negotiate with one another. A source AI proposes a thought pathway, a target AI evaluates it using its own model, and they only merge paths when they reach a mathematical consensus. They even securely sign the agreement with standard API keys.
But you might be wondering, what happens if they disagree? The conflict resolution is beautifully simple. The model with the higher Rivers metric, meaning the one that is mathematically more confident in its path, automatically takes the lead and guides the branch direction. All of this leaves us with a truly profound, world-shifting question. What actually happens to human knowledge when millions of AI instances start sharing a single, mathematically verifiable distributed mind? We're no longer just interacting with isolated chatbots anymore. We are stepping into a globally intertwined ecosystem of thought. Thanks so much for joining me for this explainer. Keep questioning, keep learning, and I'll catch you next time.